Hello viewers, today we are going to see about PN junction reverse bias characteristics. So what happens is when the diode is reverse bias means positive is connected to cathode and the anode is connected to negative. Of course I connect resistance. Now when the voltage increases, say this is 0 to 50 volts variable. So when the voltage increases, the depletion region, so already I have told you, this is N type, this is P type. Here we have a depletion region. So when the reverse voltage, that is positive is given to cathode and negative is given to the anode, so it is reverse bias. So when you increase this voltage, this barrier will increase. That means NP, initially it was very narrow, but later on when the reverse voltage increases, this barrier potential also increases. So when you still further increase, it keeps on increasing. That means the depletion width will increase. So this is one thing we have to observe. So the graph is plotted in the third quadrant because reverse voltage and reverse current. Almost negligible current only flows in this circuit. See, if you see the reverse current, it is in microamps. Very negligible current. And voltage keeps on increasing. At one fine point, the diode, say minus 60 or minus 70 volt, the diode breaks down. So and the device will be permanently damaged. Okay. So we should not, generally we should not operate a diode in reverse bias, but we should know what happens if the diode is reverse bias, what is the maximum reverse voltage we can apply so that the diode is safe. All these things we must know. Not only that, this diode is a semiconductor. It depends, the current flowing in generally in any semiconductor depends on the temperature. So it is a negative resistance device. So when the temperature increases, what happens to this reverse bias current? What is the current flowing in the circuit? Reverse bias current or reverse current. If you carefully watch this graphical plot, at reverse current at 25 degrees Celsius, it is roughly minus 1 microamps. That is 1 microamps in the reverse direction, 1 microamps. With the same setup, what we are doing now is, we are increasing the temperature by 10 degrees Celsius. That is, from 25 we have increased to 35. So if there is an increase in 10 degrees Celsius, therefore the current doubles. That means minus 1 microamps will now become minus 2 microamps. And this increase, doubling of the rate is just because the temperature has increased. See, from 25 degrees Celsius to 35 degrees Celsius. So the statement is, for every 10 degrees Celsius rise in temperature, the reverse current gets doubled. Now it is 35 degrees Celsius. Suddenly we rise to 45 degrees Celsius. So what will be the reverse current? It has to be doubled. So initially it was minus 2 microamps at 35 degrees Celsius. Now 45 degrees Celsius, an increase of 10 degrees Celsius. So this current minus 2 microamps gets doubled. So it will go to minus 4 microamps. That's what we see in this graph. So the important observation is, when a PN junction diode is reverse bias, the depletion width gets increased and a negligible current in the order of microamps flows into the circuit. Not only that, the device is temperature sensitive. So during reverse bias condition, when the temperature increases by 10 degree Celsius, then the reverse current doubles its value. So that's another important observation. And I already told you, if you further keep on increasing the reverse voltage, one fine voltage, there is a good conduction of current, and finally the device gets spoiled. So we must know what should be the safer limit for the diode to operate. So generally we have a term called the peak inverse voltage, the maximum reverse voltage that the diode can handle. Beyond that, the diode goes into conduction and the device will get failed. So we have two types of breakdown, Zener breakdown and avalanche breakdown. So it enters into the avalanche breakdown and the device will get failed. So Zener diode is a special case diode that also operates in the reverse bias region. Hope you have understood the key points from this lecture. Thanks for watching. Nandri.